Hello everyone, welcome to another one of my Leetcode videos. In this one we'll do Leetcode 167 to sum 2 where the input array is sorted. So if you haven't already solved 2sum or checked out my previous video on 2sum, I recommend you go and do that. But if you're already familiar with the 2sum problem, then this is basically the same thing. We're given a array of numbers and a target, and we need to find the two indices that sum up to the target. Now we could use the same approach as our previous video, right? So for 2sum, we were able to solve it in on time and on space, right? Because we maintained the hash map of all the elements in the array, and then iterate through the array to see if we've seen the target minus the current element in the hash map. This approach will also still work for this problem, right? But we won't be making use of the fact that the array is already sorted. So can we do better than on time and on space, given that we know that the array is sorted? Yes, we can actually do better, right? So for example, if we have 2, 7, 11, 15, which is the first example, since we know it's sorted, we know that if we start with the pairs of the two outermost elements of the array, so let's say 2 and 15, right? And our target is 9. We know that 2 plus 15 is 17, and since the target is 9, we need to reduce our sum, right? So we know that if we want to get a target of 9, there's no way 15 can be included. So we then get rid of 15 and move in, right? So we go to 11, and then we see that, okay, 2 and 11 sum up to 13, and our target is 9. So there's no way, again, 11 can be included because our target again is 9. So then we again go one level in. Then we see 2 and 7, right? So now let's say 2 plus 7, our target is 9 and it's equal, so we return these two indices. And in the converse case, let's say in this case we had a target of like 23, for example, right? So first we'll do 2 and 15, and we found that the sum is 17 and it's not yet 23. That means, since 2 is the smallest, we're already pairing it up with the biggest element. 2 can't be part of it, right? So we need to increase our sum, so we move to the right, right? So basically we take the outermost elements of the array. If it's smaller than our target, then we move the left element so we can increase the sum. If it's bigger than our target, then we move the right element down and then we continue. So if we reach a point where the two pointers are equal or past each other, then we stop. Otherwise, if we find our sum, then we return that. But we're guaranteed that we have exactly one solution, so we'll assume that we'll always find a solution. And this algorithm will be on time, right? Because we have to, we might go through each element in the array, but the space is only O1, right? So it only uses constant extra space. So with that, let's get into the coding. So we'll start with our left and right pointers. We'll initialize the left pointer to the 0 index and the right pointer to the numbers.length minus 1, which is the end of the array. And then in our loop, we'll do while left is less than right. And outside the loop, we'll just return an empty array because we can return anything here. We're guaranteed we have a solution, so we won't actually hit this case. So over here, we'll compute our sum. So the sum will be, numbers at left plus numbers at right. So this is the sum of the two indices. And then we'll say if sum is equal to target, that means if we found our target, we'll return the indices. Otherwise, if the sum is less than the target, that means we need a bigger sum. So we'll move our left element forward so that we can increase our sum. And otherwise, if that means our sum is greater than target, because it's not equal, it's not less, so it must be greater, then we move our right element to the left because we need now a smaller sum. So let's run that and see how this does. Okay, so I realized we need to return the indexes added by 1, right? So we don't return left and right, but we have to plus 1. So let's just do that over here. Okay, accepted. Let's submit. Perfect. Thanks so much for watching. I'll see you in the next video. Cheers.